I'll be recording this one so that we can have it. So the very first thing that we talked about in lesson 1 was rule 180. And when we talk about rule 180, this one here is that this formula only involves angles. Only angles are involved in this. So we said angle A plus angle B plus angle C is going to be always 180 degrees. All of the three angles, if we add them up, it has to add up to 180 degrees. That's the very first thing that we did. And then lesson number 2, we talked about the Pythagorean theorem. Pythagorean theorem. And this Pythagorean theorem, this formula only involves sides of a right triangle. Okay, so when we look at the Pythagorean theorem, this formula only involves the sides of a right angle triangle. Let's write down the formula for that one. A squared plus B squared equals to C squared. Now what's so special about C squared is that the C squared is the hypotenuse. The C squared, the C is always the hypotenuse in this formula. And then the A and the B are the short sides, and they call it legs of the triangle. Okay, those are the two short sides. And then, so sometimes the question will ask you to solve for the hypotenuse, okay? And sometimes the question can ask you to solve for one of the short sides. Okay? So sometimes in this question it could be missing the hypotenuse or missing the B, one of the short sides. And then the last, lesson 3, we use the Trig trigonometric ratios. Now when we get into the trigonometric ratios, in this case we are involved. Formula involves sides and angles. Okay, so in that formula, and there are 3 formulas for trig ratios, they are going to involve sides and angles in the same formula. So the formula are here. I'm going to write down the short formula. So, ka, toa. That's just an acronym so that we can a shortcut in terms of remembering the trig ratio. So SOHCAHTOA. So that means it's sine of theta, the angle, is equals to opposite over hypotenuse. So we're going to use the sine, that's the S, opposite hypotenuse. Okay. The other one is cosine theta, an angle, cosine of an angle is equals to adjacent over hypotenuse. So the C represents the cos, the A represents adjacent, and then H is hypotenuse. Okay, so katoa. And the last one is T, so that's the tangent. So tan theta equals to opposite over adjacent. So the T represents the tangent, the O represents the opposite, and then the A represents adjacent. Okay, so now in this case, because you are going to be given, it involves sides and angles, so the possible questions could be find the unknown side lengths. Okay, find the possible unknown side length, or find the unknown angle. Okay, so those are the two types of questions we're gonna encounter in this one. Okay, so that's that piece. Okay, so that's the whole formula that you can use for a study sheet and a formula sheet. Okay, so I'll still keep it up. Okay, I'll let you copy up to that part, and then what we're gonna do is we're gonna pick some question in assignment 3. Okay, we're going to pick some questions in assignment 3 that we'll go through together. So keep your formula sheet handy, and just put it on the side. So what we're going to do, is there anything on page 17 that you would like to see us go through as a class? Is there anything on page 17 that you want us to go through as a class? And these questions, the questions in here could be trigonometric ratios or Pythagorean theorem. So that's a really nice mix. It's a mix of questions. So is there a specific question you want to see on question 1? Yeah.
The shape of L sometimes kind of, this is a straight, is you can easily understand what, but sometimes the L makes it different. Sometimes upside down.
Yeah, yeah.
That's with one upside down is more.
Yeah, like this is the L shape that you're talking about.
Yeah, it's easy, isn't it? No problem.
But yeah, so what you could, yeah, this one here, the L is flipped onto the other side, right?
Yeah.
And then here, the L is up to here, like right there.
Yeah.
Yeah, so think
Number A.
1A. Okay, let's take a look at 1A. Okay, so let's take a look at this one in here, and it says this is what's a given information. Okay, so what do we know? Oh, some of these parts of this question involves sides, and we're trying to figure out an angle. So in this particular case, because some sides and angles are involved in the question, then it has to be one of these three trig ratios, right? Because sides and angles are involved in the question, then we have to use trig ratio. But the question is, which trig ratio are we going to use? So that depends on what we have in here. So this is your angle, okay? And then this is the 90 degrees right there. So what do we call this side? The side that has 17. Adjacent, A. Right? Adjacent because it's right beside the theta, right beside the angle. What do you call this side? Opposite, yeah? So opposite. And that's our theta. So which of the trig ratio are we going to use? Is it sine? Is it cosine? Or is it tangent? Okay, like look at this one. We got the theta, adjacent, and opposite. Which one has theta, opposite, and adjacent in it? The tangent, right? The tangent. So that's how we are gonna pick our right formula. So we're gonna put tangent theta equal to opposite over adjacent. Now, the next thing is to substitute the value. So tan is a function. Theta, do we know what the theta is? We don't know, right? Theta, we don't know how big that angle is, so we're going to put theta there. Equals opposite. Do I know the opposite side? Yeah, it's 23. Divided by adjacent. Do I know the adjacent side? Yeah, 17. So we're going to go tan of what angle? What is that angle? So it's equals to 23 over 17. How do we do that one? We're going to have the theta on by itself, on its own. So we got to make sure our calculator says degree or D. And then we're going to go 23 divided by 17. That's going to give us some decimal value. 23 divided by 17. What we're trying to see here is that we want to have the theta alone. So that means we have to get rid of tan. To get rid of the tan, we do the inverse of that. So we're going to do the tan inverse. Tan inverse, tan inverse. So we have our theta. So this is what we got when we got 23 divided by 17. And then we're going to do the tan inverse. So second function, tan inverse. Tan inverse of my answer. So I'm just going to press answer here. And it's 53.53 degrees. 53.53 degrees. Is that okay? 53.53 degrees. Yeah. Yeah, if there's anybody who needs a calculator to use at this time, I have two more. Is there anything in here that you want us to take a look at? So this question is calculating the angle. Calculating angle. Can we do letter B together? Can we do letter B together? Okay. Let's do letter B together. Now this one here, there are angles and sides involved in the question. So angle, there's an angle involved right there, and then sides in this question. So if that's the case, when you have angles and sides involved, hello Eric, we're gonna use one of the trig ratio. Okay, but which one is it? Let's see. This is my angle, so that's my theta right there. And then this is the 90 degrees. What do you call this side? A, right? Yeah, A, adjacent, right? Adjacent. What do you call this side?
H.
The C, which is the hypotenuse, right? Hypotenuse. Okay, so now let's take a look. Which of these trig ratio that has theta, hypotenuse, and adjacent in it? So take a look at which one has the theta, hypotenuse, and adjacent. Cosine, right? Cosine has a theta, adjacent, and hypotenuse. So cosine. So we're going to put down cos theta equals to adjacent over hypotenuse. So we've labeled, we figured out the equation that we're going to use. Now we're going to use it to solve for x. So cos theta, okay, theta I know, so I'm going to put theta there, 62. Theta, I'm going to put 62. Equals, okay, equals, adjacent is 19, so 19. Divided by hypotenuse. Hypotenuse is x. Okay. So in this case, we're gonna solve for x. We're gonna solve for x. So how do we do that? In this one, where the cos of 62 is, the denominator is 1. Okay, if there's nothing, we've seen that before. When there's nothing in the denominator, it's 1. And then we're gonna cross multiply to get rid of the denominator. So we're gonna cross multiply. What would that look like? X times cos 62 equals 1 times 19 is 19. Okay. Have we solved for x? That's times. So I'm going to put a brackets around it. Okay, so the x is not isolated yet. The x is not isolated yet. So what can we do to get the x isolated? Yeah, we're going to divide by now here x is being multiplied by cos of 62, so we're going to do the opposite. Divide by cos 62, and I got to do the same thing on the other side. So the cos 62 cancels out, and then we're left with x alone. So x is now alone. So x is equals to 19 divided by cos 62. 19 divided by cos 62. So the answer is 40.47. 40.47. Okay, we're talking about the length here, the x. Talking about the x. So 40.47, what unit do I put in there? Okay. This is the length, so the unit will be meters. So 40.47 meters. Okay. Is that okay? So we did question 1A and B, okay, using the trig ratio. Let's just take a look at now let's take a look at one of the word questions. Okay, so let's see if we can do a word question in here. Anybody would like to pick which word question we can do? Is it question 2, 3, or 4? Doesn't matter. Which question would you like to see us go over or take a look at? The 3? Question 3? Yeah? Okay, let's do question 3. 4 or 4? Which one? 3 and 4? Okay, 3 and 4. Sounds good. Okay, let's see here. So the Manitoba Legislative Building is 77 meter tall from the base to the tip of the Golden Boy. From where you are standing, the angle of elevation to the top of the highest point is 30 degrees. How far are you standing from the point directly below the Golden Boy? So they gave us a triangle in here. So this is the legislative building. This is the building. And from here to here is 77 meters. And then they said that this is your angle, 30 degrees. And we're trying to solve, okay, close up. Solve for x. Okay, so what's our strategy? Can I use rule 180? Can I use rule 180 in this case? Can I use the Pythagorean theorem in this case? Or can I use the sine, cosine, or tangent, the trig ratio? Okay, look what information is involved in the question. We're involved with, in this question, it has a theta. So this is the theta. You got side x, which we just don't know what it is. And then we have this side. So that, okay, because the question is involving sides and angles, we're gonna use one of these 3 things. Okay, that's how, okay, I'm trying to tell you or give you a hint on how to figure out which formula to use. Okay, so it has to be, because there are some sides and angles involved in the question, it has to be one of these trig ratio. Now, the next thing that we're going to do is we're going to try to figure out, well, which one of the 3. Well, that depends on what information we have in here. So this is the theta, 30 degrees. This is the 90-degree angle. call this side? Oh, that we'll do the 77. That one is the opposite. Opposite. Okay? Because it's right across. What do you call this side? Adjacent. Right. Okay. Now, which trig ratio are we going to use? We have theta, adjacent, and opposite in the same question. So which one is it? Tan, cos, sine, which one? Tan. Okay, tan, right? Because it has the theta, opposite and adjacent. Yeah, so we're going to use tan. So tan theta equals to opposite over adjacent. Now let's substitute. So tan 30, opposite is 77, adjacent is x. If there's nothing in the denominator, it's 1. So we're going to cross multiply here. Oh, I'm going to run out of room in here pretty fast. So I'm going to cross multiply, and we're going to get, I'll just put it right there, x times tan 30 equals 1 times 77 is 77. We need to solve for x and have it alone. So what are we going to do? Or what are you? Yeah, what are we going to do? Huh? Divide, right? We're going to, because this is multiplied, we're going to do the opposite of that, would be divide tan 30. Divide tan 30. So tan 30 cancels each other out. And then the x is alone finally. Figure that out. 77 divided by tan 30. So it's 133 point, I got 36, and then the following number is 7, so that's 133.37. And the unit would be, okay, because this is meters, would be meters. Oh, sorry, you can't see that. 133.37 meters is our final answer. Is that okay? Is it getting better? Yeah, did you get it? Yeah, 77 divided by tan of 30. Is that okay? And we'll try number 4. Try question 4. Okay. Looking at this one here, they gave us a picture already. It says here the ladder is 9 meters in length. So this is the ladder, 9 meter in length, leans against the side of the wall. So this is the wall and it's leaning on it. The bottom of the ladder is 1.5 meters from the base of the wall. So this is the wall. The bottom of the ladder is here, 1.5 meters there. Determine the measure of the angle between the ladder and the wall. Sorry, the ladder and the ground. Right there. So, how do we decide, and what do you think? Verbalize what we're seeing here. What do you see? I see sides and angles involved. Sides and angles in in the triangle. Okay, I see sides and angles involved. So that means I will use trig ratios. Okay, one of the trig ratio. This is what I'm actually writing down what I'm thinking about. Okay, I see in this picture sides and angles. These are the two sides and this is an angle involved in the same question. So that means I'm going to use a trig ratio. Okay, the question is, which trig ratio am I going to use? Well, that depends on what these things are. So this is my theta. This is the 90-degree angle. Now let's see. What do you call this side where the ladder is? Hypotenuse, right? Perfect. Hypotenuse, because it's right across the 90-degree angle. Good. Now what do you call this side? Adjacent. Yep. Okay. So now we ask ourselves, I know that's hypotenuse, I know that this is adjacent, and I know that's theta. Now which trig ratio are we going to use? So take a look at your formula sheet. Which trig ratio are you going to use? Give you a moment to take a look at the trig ratio. Is it sine? You say cos? I heard say cos. Yeah, absolutely, it's cos, right? Because the cos has adjacent and hypotenuse. Adjacent and hypotenuse. Yeah, perfect. So we're going to use cos. So cos theta equals to adjacent over hypotenuse. So cos theta. Okay, what's my theta? Oh, I don't know what my theta is, so I'm going to put theta for now. Adjacent. Oh, I know what my adjacent is. It's 1.5 meters. 1.5. Oh, I know my hypotenuse. My hypotenuse is 9 meters. Okay. Now, because we're solving for theta, we have to get rid of the cos. The only way to get rid of the cos is the cos inverse. So we're going to eventually do the cos inverse here to have the theta. So first, I need to go 1.5 divided by 9. It's gonna get us 0.16 repeating. And then finally, we're gonna do the cos inverse. Second function, cos inverse of what I got earlier. It's gonna be 80.40, but then I look at the third number on the thousandth, it's 5, so it's gonna be round to 1. So 80.41 okay, 80.41. What's a unit? Talking about the angle. So the angle has to be in degrees. Perfect. You got it. So 80.41 degrees. Is that okay? Yeah. So we have a little bit of time.